Hi guys, welcome to my channel. Alright, today we are going to discuss about distribution board and the inverter load balance. Alright, though I have a course specially set aside for this particular topic. Okay, but for the purpose of some of us who are already in the field, let me just summarize it so that whenever you have to incorporate an inverter system into distribution board, you know what is obtainable. Okay, now oftentimes find out that some of us were in the habit of installing a separate distribution board or a separate consumer unit whenever I want to install inverter system. Something like this. We now come to distribution board and determine a particular circuit that is dedicated to this phase, to one particular line, and share them to these other two lines, and now feed inverter to one of the line. So that is method one for some people. Then some people will install a different panel like this, consumer unit or DB, and they isolate those essential load that is required for the inverter to feed, and they now install them into this particular DB. All right, so I have a solution for you guys. You no longer need to do that. You don't need to install a separate distribution board or a consumer unit. You don't also need to dedicate one of the line for inverter to feed. Okay, because if you do that, you are altering the load schedule and the circuit analysis of the distribution board. All right. Like I said, I have a course for this, so I would have time will not permit anyway for us to go through each of these detail of this distribution board. But let me just summarize it for you. Okay. So each of these, for example, this circuit now is simply telling us that veranda, lobby, boys' room, sitting room is where this particular circuit fit to. That is circuit description. Okay, we also have this table as well. This is where we do our load analysis. Whenever we finish installation, we now generate this load analysis. Okay, and define the installed load, and also define diversified load, where we apply diversity factor, after which we determine which of the load that is diversified and which of the load that is total load installed to the distribution board. We analyze it this way. So when we analyze it this way, we now laminate this and paste it at the back of distribution board for future reference. Whenever I want to carry out alteration or I want to carry out adjustment on the distribution board or troubleshooting of kind. So you will make reference to that particular information. You also understand the segregation of the load within the distribution board. So for that purpose, we don't need any alteration that will warrant you changing the circuit analysis here. So whenever we put a description that a particular circuit is supplied to a particular area and put the labeling, we don't need to swap this circuit. We don't also need to change any of the circuit arrangement in order to install inverter or to factor any other load supply. Okay, so the default setting of the distribution board from inception should remain the way it is set up. The default setting should remain that way while you factor in your inverter supply to the distribution board. Okay, what I mean is this: the setting, the arrangement, circuit schedule, circuit calculation, circuit analysis, whatever thing that was carried out on this DB should remain that way. It shouldn't be altered, okay, in the course of installing your additional distribution board or putting inverter. So for us to maintain the default setting of the distribution board, so we have to do what we call relay interface. We need to interface distribution board with a relay system, a relay device. So that is how we do to install our inverter system. Okay, so that is what we're going to do. I will teach you how to do that so that I don't need to install additional panel, consumer unit, or isolate some of the circuit from one particular line and put them on two phase and now dedicate one line for inverter here. If you do that, the load is no longer balanced, and some of our end user also need what we call backup power. Okay, standby power source, the generator or any of the related source of supply. So if you do that, if the three phase is coming from genset, you will no longer be balanced, and you're all aware that our three phase from genset supply is expected to be balanced as evenly as possible across distribution board. Okay. All right. So for us to do that and maintain that principle, we don't have to alter the arrangement of the distribution board because that default must remain that way. Okay. So what we need to do is to leave the setting of the distribution board while we incorporate our inverter supply in that distribution board. So I will show you how to do that. Okay. So in a brief summary, but the full detail and comprehensive study about what I'm explaining now, I have the course. So if you contact me through here, I'll send you the video, send the video across to you from beginning to the end. All right. Okay. So I have it up to like about 7 videos that you use to go through DB calculation, DB analysis, power factor analyzer, and all the rest, and voltage drop calculation for you to understand more about DB studies and the internal distribution system of a building, the calculation that is associated to that. Okay. All right. So first of all, let's test this distribution board before now I start to carry out our modification by interfacing a relay device. So what I want to do is this. I have a circuit now, 1, 2, 3, dedicated for lighting circuit. So my lighting circuit is 1, 2, 3. Okay. Then this 1, 2, 3 is my radial circuit 2 and ring circuit 1. Then these are my power circuit. This other one, they are my power circuit. Then I have spare here, 3. Okay. All right. So I want to incorporate the inverter according to essential load that is needed. Okay, you know that inverter, depending on the end user requirement, if the end user can size the inverter to carry the total load of the demand of the building, it's okay. But you cannot do that. You now size inverter based on the essential load. What are the essential load? Essential load include the lighting points and the 1 or 2 power circuit or ring point that is going to be added. So these are the essential load that you normally use on regular basis. So you make sure you identify your essential load and now send the inverter to those essential load circuit. So that's what we're going to do now. So we are doing that by interfacing a relay here. Okay, but before then, let me just test distribution board and use this load, this particular pilot lamp, to indicate that this DB is working first. Let's first of all identify that DB is functional first before we now modify the DB by adding our relay device. So let's do that in a short while. So just watch. This is my lighting load, one of my lighting circuit. Let me use it to feed this lamp. Okay, let's feed this lamp. This lamp will come up as soon as I simulate. Then this one too will feed this other lamp. Okay, then this other lighting circuit again will feed this other lamp. Okay, we feed this other lamp. All right, so these are my essential load. Lighting circuit is part of our essential load. When you come for inverter installation, we need to identify our essential load. It's essential because it's lighting circuit. You need to light up all your apartment first before you now engage other power circuit to go to inverter. So let's choose one of the power circuit here that inverter can carry. So let me assume that inverter can carry one of these AC. So let me feed AC to this lamp. Let me use this one to illustrate that once this one come up, it is assumed that AC is running. Okay, so that's what we are doing. So I feed them, then put their neutral on one common bar. Okay, so this is the neutral. You should take common neutral. This one come here. This one go here. Then I should feed them from this my neutral bar. Okay. Okay. All right. Okay, now let's test the distribution board. This is 3 lighting circuit that I have. I define them as my essential load because I want to feed them to inverter as well after this first step. The next step is to break them up and interface with a relay device. So let me assume that inverter will also power one of my air condition. That's why I want this one on. So let's first of all energize my normal default setting of the distribution board. So I put on my DB. All right, look at my load on. So my DB is working now. Okay, I shut down the DB, the power go off. So my DB is now working. So now let me modify DB by interfacing the relay device. Let's cut off this line and put in our relay contact. Okay, just in a all right, now we are done. Okay, so look at the relay interface. One, two, three, four. These are my relay interface. I just interface them with relay contact. Okay, then this is the relay coil. Okay, so what step one is to bring in your relay here. Okay, let me show you the simpler way. Okay, take a look at this. Take a look at this. This is a relay module. Okay, this relay module comprises of 8 circuits. So I can use this relay module for 8 circuits to power 8 devices or 8 circuits. All right. Now we use this one for home automation to interface our PLC with distribution board. We have a lot of them, different voltage range as well, DC type, AC type. Okay, any voltage you need, current capacity. After your calculation, you now determine your contact rating. So this is what we need. Interface, insert this inside into distribution board. Then this connection you have here, this common, normally open, normally close here. I have it here. Look at it. These 3 terminal, one is common, one is NC, one is NO. So one of this one is going to be here. This second one is going to be here. Then this common is going to be here. So these 3 terminal represent here. Then this other 3 terminal represent here. So this one is for 8 circuit, but I just did 4 circuit here. So if you cannot afford this, then you can now go and buy singular relays. This is singular relay. Insert them, just put them into your distribution board. Look for ray, terminal ray, okay? Then insert it, then put your relays, okay? Install that panel ray and put your contact the relay. This one is just one particular, a singular relay. Look at the coil here. So once you must understand how relay functions before you understand this connection, please. Please, I have a course for relay logic as well. Okay, after 2 days or 3 days, you are done with relay logic. So I'll teach you the functions and configurations of relay. Okay, I have a course for that. So you must understand how relay functions before you understand this logic, this connection. It's very simple. The final outgoing here should be terminated to NO, all of them. Any circuit you want to interface with relay, terminate them on NO, normally open of your relay contact. Then inverter should go to NC. Then the common of that same contact should go to the final circuit outgoing. Okay, final sub circuit that is going to the load should terminate to the common. Another thing, bear in mind, the relay nameplate should also be noted. Like this one I use here, this is the nameplate. 15 amps is the contact rating of this. The contact rating of this particular relay that I use is 15 amps, 50 Hz, and 230 volts. That is the nameplate of this relay. Then the information of this relay is this. So make sure that the relay you are using to interface the current carrying capacity of the contact is enough to carry the load of the circuit you want to interface with. For example, this is from my calculation here. I use 5 amps for my outgoing final circuit of the lighting circuit. These ones, I use 5 amps. After your load calculation, you should be able to identify the current carrying capacity of your cable, the size of cable that you need for your outgoing, and your breaker size that you need to protect the circuit. It's through calculation you identify them. After your calculation, you now choose cable size and choose breaker size. Okay, take note, you shouldn't buy distribution board with breaker in it. You should buy breaker differently and buy distribution board enclosure differently. Breaker should be purchased according to your calculation. Okay, all right. Now, this is how to interface your relay. Take away this. This is how to interface your relay with the inverter. So let's just illustrate this. Let's just simulate so that you see how it functions. All right. So simulation now. This is my DB. My DB is on. My DB is on. Supposing my utility is available. If my utility is available, it's coming to DB. If my national grid, if my standby DG, the genset is also available, it should also come to distribution board. Whichever power that is selected, that is coming out to DB, I should have my load. This is my load output. Okay, like I said before, I use three circuits to represent these three. And I use one of the power circuit to represent this indicator. So my DB is up, is active, is coming either is active through the national grid or is active through your genset. So whichever one that is active, my load, I should have my output. All right. Now, when my inverter, when my inverter is on, my inverter should be on. Then when the source of power here is out, look at, I still have my load on because there's inverter here. Okay. Take note, remember that inverter is normally an automatic inverters. Okay, automatic inverter. So advantage of this is this. Normally, the normal setting of inverter system is that when the power is active, okay, when the supply is active, the source of power is active, inverter switches to charging mode and cut off the output. Okay, that's when the inverter cut off output and switches to charging mode, you will still have output because the internal relay of the inverter is switching that source of power to your output. That means invariably your inverter is working, doing two jobs. The relay that is switching the supply directly to the output is on because it now bypass output of inverter and give you normal supply. Then when the inverter is on, when the supply is disengaged, you have power outage. Okay, inverter now gives you output back to your supply. Now, but for this configuration now, that particular internal relay that is switching back to your supply, to your output here for your GB, will no longer be needed. We don't need the services of that particular relay any longer because there is a relay here that will do that job. So relay inverter can only now concentrate on recharging the battery, charging. I don't want the output from inverter. What output I need from inverter is only when the source of power is out. When I have my power outage, okay, let me repeat again. Inverter function conventionally is designed and programmed such that when the power is available, inverter now bypass the output. Inverter take away output and they bypass the supply and give you output. So that particular time, the power when the power source is active, the power coming from inverter is not the inverter output. It's actually your source of power, the source of energy that you have, either is national grid or your genset, whichever power that is active. That is what inverter is giving you to the output. The only moment when inverter gives you output from inverter is when the source of power is not active. When the input of the inverter, I think I have, let me show, just bear with me, let me show you. Let me just give you one inverter illustration. Just hold on. Okay, right. Now just pay attention. This is typical representation I use for the inverter. This is solar, and this is charge controller, and this is your battery. Then this is your inverter. Now this is my input. This input is 230. All right. Now when this input is not active, when the input is not active, national grid is not active, okay, this inverter, this this battery will be inverted. The battery backup will be inverted and give you AC here. You have output here. But when this input is active, inverter now internally doing something like this. Let me do something. Inverter will internally, there's a relay internally that will give you this, that will supply you this, will give you this power by bypass, through a relay here. It will send this output, this input back to you from output. You'll be having output here. This output that you have belongs to this supply. It does not come from inverter's output from inverter. Inverter will not give you this until this power is cut off. So when this power cut off, that is when the inverted energy here will come to output. But provided I have input here to the inverter, the output I'm getting here is not the inverted output. It's the same input I have here that I'm getting here. Now, When the inverter is giving me output, is sending my input to my output, giving it to me, is giving me exactly what is available from my national grid or what is available from my genset. Any source of power that is supplied here is what I'm getting here. Until here is cut off, that is when the inverted energy here will come to the output to give you supply. All right. So if that is carried, let's go back. Let me explain to you again. All right. Now let's come back here again. Now, that is the way inverter is set to operate. But with this particular uh, additional innovative idea that I bring here now, when inverter, when there is no when there's input here, let me simulate. When there's input here, inverter is not giving me output. Take a look at, I have output here, but my inverter is not on. I put it off here. Even if I put the inverter on, it's not giving me output here. What I'm having here is my normal power that I have here is what I have here. So inverter is not giving me this. Okay? Because I have a relay here that is being powered by this supply. When this relay is being energized, inverter power, look at my inverter power, look at it. It's coming to end here. It's coming to this NC. Look at my inverter. See my inverter output. Look at it here. It's not working. 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 The relay, I've cut it off. So I'm using my normal supply, being it standby or being it coming from national grid, is what I'm using at my circuit here. It's not coming from inverter. So my inverter will now concentrate on charging the battery. But when this one is cut off, when my national grid or my genset is cut off, that is when my inverter give me output through my battery inverted energy. Okay, I hope it's understood. Or you have to register the course. I will explain more and give you more illustration through diagram. Okay, all right. So this is how to convert, how to interface distribution board with inverter without requiring you to install additional panel, additional consumer unit or additional distribution board, or beginning to determine the default setting of distribution board in order to incorporate inverter to one of the line. No, it's not ideal. This is the more professional way of doing it. Inverter will be there so that the load balance of this DB will remain untouched, so that three-phase generator will remain balanced and national grid balance load will remain balanced without changing or altering the circuit arrangement of your distribution board. So this is the more innovative way of doing inverter solar installation. Okay, all right. So thank you. I want you to share this information to the appropriate body, whoever that require this particular innovative idea. Also share to your loved ones and students. Then also contact me through this contact. Okay, so that I will send you the video on how to do this load balance from step by step, from beginning to the end. Okay, and I always advise you, you don't just go to YouTube to download video and learn all this without knowing the point 1 to point 2. All right, detailed information and the paid information is more comprehensive than summary of such as this. Okay, so if you need more elaboratory about this particular innovative idea, you now contact me on this. I send you the full comprehensive video on beginning, on step by step, on how you understand even virtually everything that has to do with distribution board. I will give you the detail before you now understand how to integrate a relay system into distribution board. Okay, like I told you before, this is the ideal way of doing that, more professional way. But if you cannot afford buying this, if you go to Amazon, you can find this relay module. That is where I buy from. Buy from Amazon. You have a lot of it. How many channels you need, you can get it there, depending on your configuration. That is the more the ideal way of doing that. But if you cannot afford that, please do well to use this type of relay, singular relay. Like I told you before, this relay, the current carrying capacity of the relay coil, relay contact must be capable to carry the load of the circuit. Okay. Like for example, this particular one, I use 15 amps. Why I use 15 amps is because my lighting system here, they are all 5 amps, but my AC here is also 15 amps. Okay, and I use one singular relay that comprises 4 circuits, 1, 2, 3, 4. That is why I use 15 amps. Supposing I use 3 circuits only, I didn't use power circuit, and this is just 5 amps coming from here. So I would have used 10 amps here. The relay contact should be 5 amps, 10 amps rather. Okay, but because I use one relay, that will include power circuit and also lighting circuit. So I now use the AC to size the relay. I use the AC power to size the relay. Okay, see the reason why I use 15 amps here. All right. Okay, so thank you.